So we're going to finish up the notes on the chain rule from our packet. And I never really did give you the official formula for the chain rule. So if you are taking the derivative of a composite function, this is f of g of x, so we've got this function inside another function, and you're taking the derivative with respect to x, then you take the derivative of the outside function, that would be f, the derivative of f, with the inside left unchanged, times the derivative of the inside function, which would be g prime of x. So that is the formula for the chain rule. I like it with words, the derivative of the outside function with the inside left unchanged times the derivative of the inside function, because that's actually probably going to be easier to remember than a formula. So here we have we don't actually know what f of x, g of x, and are equal to. So we have to find h prime of x, and then we're going to plug in values. Remember, you don't plug in the values until after you find the derivative. So I'm going to start with number 16, and so we're going to get h prime of x equals. So this is a power rule problem. So I'm going to do 3 times f of x, so the inside left unchanged, drop that down a power, times the derivative of what's inside, which would be f prime of x. So this is my derivative. Again, power rule, 3 times f of x, because it's the inside left unchanged, and then drop the power down, times the derivative of the inside function. Now, I want to find h prime of 2. So now I can just plug in a 2. And look up at the values that they gave me. So f of 2 is -3, and we're going to square that. F prime of 2 is 6, so 9 times 3, 27 times 6, okay, 162. Next one. Now keep in mind, I cannot just say f squared of x, f of x squared minus g of x squared, because if I did, I'd be killing a puppy. So I'm going to use the chain rule. So to get h prime, of course I'm using the chain rule. This is a packet on the chain rule. So I have to use the power rule first. That's the outside function. The inside function is this difference. So we're going to have 2 times f of x minus g of x. And then I would drop the power down, but then it would just be a 1. So that's the derivative of the outside function with the inside left unchanged, times the derivative of the inside function, which is just f prime of x minus g prime of x. Okay, so that's what I get for the derivative. Now I'm ready to plug in a value. So I'm going to have 2, and I'm not going to rewrite it. I'm just going to do f of 2 is -3 minus g of 2 is 3 times f prime of 2 is 6 minus g prime of 2 is -2. So I get 2 times -6 times this 8. So we get, calculator handy, -96. And that would be my answer. Okay, next one. I'm using different colors since I run into everything here. I might do this one down here. First of all, I'm going to rewrite this. H of x equals, let's change this to 4g of x minus 1 to the 1/2 power. Okay? All right, so then h prime of x, I'm going to start with the power rule because that's my outside function. So I get 1/2 4 times g of x minus 1, because that's the inside left unchanged, to the -1/2 times the derivative of what's inside. So the derivative of 4g of x is 4, and I'm going to put a bracket here, 4 times g prime of x minus 1, because the derivative of the x is just 1, and the derivative of negative 1 is 0. Good thing, because I don't have any room. Okay, so once again, the power rule gave me this, with the inside left unchanged, times the derivative of the inside function, which is 4g prime of x minus 1. Now I'm ready to plug in. So I get 1/2. I'm going to have 4 times g of 2 is 3, minus x is 2, so I'm going to put a 2, minus 1 to the negative 1/2, times 4, g prime of 2 is negative 2, and then we're going to have a minus 1. So I get 1/2. Here I'm going to have 4 times 3 is 12, minus 2 is 10, minus 1 is 9. So I get 9. I'm going to leave it like this so that I don't make a careless mistake here. So here we're going to have negative 8 minus 1, which is negative 9. Now, remember that the root, the half is a square root, and the negative tells me to flip it to the bottom. So that's going to be the square root of 9, which is just 3. And then flip to the bottom with the 2, puts a 6 down here. So I actually get negative 9 over 6, which is negative 3 halves. So that is correct. Amazing, I didn't make a careless mistake. So here we have our 3 answers for these. Okay, next 3. All right, so here we go here on this one. So this actually is just going to be h prime of x. This is actually the definition. Is going to be the derivative of the outside function with the inside left unchanged times the derivative of the inside function. So that is exactly the definition of the chain rule right there. So then h prime of 2, okay, I'm going to plug this one in. All right, so we have to evaluate f prime of g of 2. All right, well, first we got to know what g of 2 is. So when we get g of 2, we get 3. So then I have to know what's f prime of 3. Hopefully we have that up here. There it is, 4. So then this whole thing right here, f prime of g of 2, you start with the inside and evaluate it, take that answer, plug it into the outside, so we just get 4. And g prime of 2 is negative 2, so my answer is negative 8. Okay, next one is just going the other way, but it's still the definition of the chain rule. So we get h prime of x equals the derivative of the outside function with the inside left unchanged times the derivative of the inside function. So I get for h prime of 2, we have g prime of f of 2 times f prime of 2. So f of 2 is negative 3, so then I need to know what g prime of negative 3 is, and it's negative 1. So this whole thing right here is a negative 1, and then f prime of 2 is 6, so my answer is negative 6. If you didn't follow that, you can go back and rewind. Okay. So next, I'm going to use that same idea here. So h prime of x, the derivative of the outside function with the inside left unchanged times the derivative of the inside function. So this is like having a negative 1 times f of x. So when you do the derivative of the inside function, it's just going to be a negative 1 times f prime of x. So then h prime of 2, we get f prime negative f of 2 times negative f prime of 2. So I have to start by finding f of 2. So f of 2 is negative 3. So then the opposite of that is 3. That's what gets plugged in to f prime. So f prime of 3 is 4. So this whole first part is 4. Then I need f prime of 2, which is 6, but I need the opposite of that, which is negative 6. So I get negative 24 as my answer. All right, so that's how you do those. Then I thought, this is on the homework page, but I figured you'd be asking me about that anyway. And I thought this looks fun and I just kind of wanted to do it. So here we are. So for problem 23, I'm trying to find h prime of 1, and somehow I'm going to have to use this graph because they don't give me values, so that will be interesting to do. So let's start here. I might need more room, so I'm going to do it down here. So if I do h prime of x, I'm going to use the power rule because that's the outside function. So I get 2 times f of x plus g of x to the first power times the derivative of what's inside, which would be f prime of x plus g prime of x. And I'm asked to find h prime of 1. So I'm going to have to know what f of 1 is plus g of 1. And I'm going to have to know what f prime of 1 is plus g prime of 1. Okay, well, they give me f of x and g of x. I can see those functions. So I can actually evaluate f of 1. I'm going to look on here and find when x is 1, I see that f of 1 is 3. Okay, so because this would be the height, this is when x equals 1, the f of x value would be 3. So I'm going to put a 3 there. G of 1, so when x is 1, g is 2, because g is the dashed, looks like some kind of absolute value function. So we have 2. And now I need f prime of 1. Well, I don't have that. So remember what f of x represents, or f prime of x? We think of the derivative. And what do we think about when we think of derivative? We should, hopefully you're thinking this right now, it starts with an S, slope. So this is linear. So what is the slope? Well, it's a constant slope. Notice that we go down 1 and over 1. So the slope of f of x is negative 1. So f prime of x is always negative 1 because the slope is always negative 1. So f prime of 1 is negative 1. And g prime of 1, notice the slope here. So if we go up 2 and over 1, so we have a slope of 2, and it's consistent. It's a constant slope because this is a line. So the slope of a line is going to be that constant value. So it's up 2 over 1. At least for that side, this would be down. So this is going to be a negative 2 on that side. So we get a 2. So now I have 2 times 5 times 1, and we get 10. And that is our answer. See, wasn't that fun? I'll tell you what, I don't want to hog all the fun to myself, so I'm going to leave number 24 as part of your homework because, I want you to have fun too. So anyway, so that should wrap it up for Unit 9.